So we're here back with another episode live from the Mid-Atlantic Hardscape Trade Show, or better known as MOTS. And these episodes are going to kind of come out in the coming weeks. So we're going to try to talk more about the topic that we have for today rather than the show, but having the opportunity to see Paul Cureton here, just a wealth of knowledge and an engineer with Oldcastle. And Paul, thanks for joining us today.
Yeah, thanks for having me, Craig. Really appreciate it.
Yeah. So you're an engineer, right? Is it civil engineering that you do?
Okay. I'm a licensed civil engineer in the state of Illinois.
Okay.
But we provide engineering assistance throughout the U.S. and Canada.
Okay. So tell us a little bit about your background and how you got into doing that, if you don't mind.
Yeah, no problem. I grew up working in the contracting business, mostly underground utilities, and my dad's like, "Hey, you should go into engineering." And, my initial thought, I really wanted to go into teaching. I wanted to be a teacher. And he kind of pushed me into engineering, and I'm glad that he did. I was a consulting civil engineer for over 20 years, and I did a lot of permeable paver designs, several million square feet. I oversaw the design, the construction, and the permitting. And most of them, I actually was the construction manager as well. So, that's one of the things I think that kind of separates me from a lot of the engineers of today, because I was out in the field. I know how things are built, and I was really good at visualizing things in 3 dimensions and figuring out how to really put the information on the plans to get it built. And then, I started doing some consulting work for Oldcastle and for Belgard in Chicago. And the sales manager there introduced me to my current boss, which is Brad Meyer. And it's all history from there. I've been here for 7 years, and that's the longest I've ever had any job in my life. So it's been a great experience. I really like what I do. I like working with contractors. I love working with engineers, architects, landscape architects, and our salespeople, kind of educating them.
Right.
So I ended up being a teacher. I teach people how to do permeable pavers, and that's really what I like. It's a really a fun job, and it provides me a lot of opportunity to get out and work with all of our people throughout the U.S. and Canada.
And I think what's interesting is when people in this industry anyway is when people think of engineering, they immediately go to retaining walls. Which you also have that, available on your team, but what you do is more specialized in permeable pavement and that kind of thing, right? So can you explain, without being super technical, but kind of what the process looks like for that? And is it just is it the construction, but you also have to look at water retention and detention and all that stuff. So kind of explain what you do and how you help people design either parking lots or roads or driveways.
Yeah, there's a lot of misconceptions out there about permeable pavers and permeable pavements in general. Now, permeable pavers, in my opinion, I work for Oldcastle. We sell permeable pavers, but and I believe this 100% that it is the best permeable pavement system out there. Why? Because it's easily maintained. You can regenerate that system. You can restore it back to pretty much 100% through the restoration process that we have in our O&M guide. So permeable pavers really, to me, that's where everything should be.
Right.
All parking lots built now should be in a permeable paver. But for this reason, it's a 5-in-1 stormwater control measure, right? They provide a heavy-duty driving surface. The whole surface is your stormwater inlet, so you can get rid of most of those big catch basins and all those inlets. They provide a really high level of water quality. Right. You remove up to 98% of total suspended solids sediments. You can get 80 to 85% nutrient removal. That's phosphorus and nitrogen. So these are the things that a lot of the regulatory agencies are looking for, which are generally considered TMDLs, total maximum daily load, and that's what the EPA is kind of regulating. So you get driving surface, stormwater inlet, high level of water quality. You get conveyance, so you can move the water through the site like a pipe would.
Right.
So that so you can get rid of most of the pipes, most of your inlets, and you get storage. That's the 5 pieces: driving surface, inlet, or capture, water quality, conveyance, and storage, right? And see, because I get asked all the time, well, what's the cost of permeable pavers versus asphalt? You're asking the wrong question.
Right.
Permeable pavers cost more than asphalt. Yeah. Hands down. Anybody tells you something different, they're selling you a bill of goods. But what you have to really look at is the total stormwater management cost for a project. And most of what I'm talking about is commercial, but there are benefits on the residential side as well. Really, when it comes to impervious cover. But what you want to, you got to look at the total cost of your stormwater management. And when you look at that, you look at it that way, most of the time, permeable pavers are going to create a solution that's less expensive.
Right.
And that's what people are blown away when I tell them that. They're like, what? I can do pavers and save money?
Right.
Because what we see a lot of times, too, is when properties are beside a paver driveway or a paver street, what happens? The property values go up. That's anecdotal. I mean, you look on Zillow, you look at properties where we have these kind of solutions, the property values are 10, 15, 20% higher. So it's a benefit. And on the residential side, if you have a 30% impervious cover limit, a lot of municipalities will allow you to do permeable pavers and go above that 30% limit.
Right.
So if you want to put in a pool and they told you can't do a permeable paver deck around your pool, and now you can get there. And not all municipalities allow that, but a lot do. It depends on where you're at. It's really localized.
It's interesting you bring that up because we just finished a project over the summer, and we had to do infiltration trenches. So the house, was there. The driveway's there. These are all impervious surfaces, right? And we install pools. So we sent this plan to the city, and they said, you have exceeded your impervious surface, which I knew we were going to do, because I think you have to be 38 or 40% there. So,
right.
So they're really making an effort to control runoff and stormwater and all that. It's an older, well-established area that's, less grass surface areas, So, so one of the things that I asked them was, well, if we did, because yes, the pool does count as impervious, which seems weird because it holds water. But if it overflows, it's going to be a problem. Right. So one of the things I asked was, can we do a section of the patio in permeable? And the answer I got was no. We're not allowing contractors to do permeable surfaces because they get installed improperly. So I think they were doing this for a while where you could do a certain portion of the patio impervious, and then you could do a permeable section to allow for the, so it wouldn't count against the impervious surface. So this is becoming, even in the Midwest where I live, it's becoming more and more of an issue. So they've required us to do infiltration trenches. So we had to bury gutters into an infiltration trench, and then all our groundwater under our patio also went to the, and we use an open graded base. This is something we can probably get into a little bit here in a minute, but
for sure.
So it was interesting that was their response. So why are we installing permeable systems wrong?
Well, I mean, the issue really lies in the fact that it's a very new technology.
Yeah.
And a lot of civil engineers are very cautious by nature. Yeah. They're conservative.
Yeah.
And and they don't like change. They don't like new things. They've done the same thing the same way for centuries, essentially. So it's hard to get people to change. There's a lot of systems out there, permeable pavements, other than pavers, that do have issues with clogging and with failures.
Right.
And unfortunately, they lump all permeable pavements together in one big heap.
Right.
And there are huge differences between permeable pavers versus porous concrete or pervious asphalt or some of the other products on the market, like the grid pavers. And some of the plastic grids and things. Permeable pavers are much more resilient. You can maintain them. You can evacuate the joints. You can suck that joint material out, and you can basically restore the system back to 100% permeability, which most of the other systems you can't do that.
Right.
So that it's an education process. That's a lot of what I do. I go out and talk with these municipal engineers, with engineers who are designing these systems, and make sure that they understand really the differences are key.
Right.
The similarities, a lot of these systems are very similar. You can design them the same way, but the differences are really what sets our system apart, because you can have heavy duty, you can have tractor trailers driving on it. You can't drive a tractor trailer which is turning on top of porous concrete.
Right.
And then porous asphalt, it just really doesn't work very well. It's a sticky substance to begin with, so any sediment that gets in there sticks.
Yeah.
And over time, all those pores collapse, so it becomes less and less pervious over time. So, with a permeable paver system, you're going to have that permeability for the life of the system. What's the life of the system? 40 to 50 years.
Wow. Yeah.
Where, most of your asphalt and concrete pavements, their service life is about 20 years. So you're looking at least twice the length of time. That's big for homeowners. That's big for owners. And when we do life cycle cost analysis, looking at the life cycle of a permeable paver stormwater control system versus a conventional system, almost always, especially when it's asphalt, we're comparing it to, almost always it's cheaper for the life cycle.
Right. And
a lot of times it'll be cheaper up front too.
Yeah. And another thing that I think is interesting is snow removal. That's a huge factor that a lot of people don't think about. So I know in Chicago, this is kind of where I learned about this. I saw a lot more parking lots when I was traveling there that were permeable. And one of the explanations was when it snows, we plow it off. And it doesn't, you don't get the melt and refreeze, because when it melts, it just goes through the system. And honestly, you're getting more warm ground temperature, right? So it's, in some cases, it melts faster. Is that correct?
Oh, absolutely. If you get less than, say, an inch of snow, you're not going to have to plow, because it's going to melt off, because there's a cave effect.
Right.
You go in a cave, it's almost always right in between like 55 degrees to 60 degrees.
Yeah.
That's what happens in a permeable paver system. It's all air voids, and that air stays warmer than the ambient air temperature. So it's almost, I wouldn't say that water never freezes in a permeable paver system, because, in Chicago where I live, we have weeks that are below zero.
Right.
But there's a couple things. How much does water expand when it freezes, Craig?
I don't know the exact amount, but it does expand.
Roughly about 10%.
Yeah.
Okay, what's the void ratio in the aggregates we're using on a permeable paver system?
Well above 10%.
About 40%.
Right.
Okay, so even if it does freeze, it won't heave. You get no frost heave, and that's the big advantage of using open graded aggregates in your assembly.
Right.
Because once it freezes, if it does freeze, it can't expand enough to push. Because when you use a dense graded aggregate, the water gets into all the little pore spaces, and when it freezes, it pushes, and and then your pavement surface is all crazy, because it's so there's especially in a freeze thaw environment, permeable pavers are I've used permeable pavers to solve frost heave issues. Like a school I worked for, on the north side of the school, every year it was emergency egress from the school out of the gymnasium. Every year they would have to take out the concrete because it would heave. And it would block the door. They take out the concrete, and every summer they re-pour it. We put in permeable pavers in 2011. They've never touched it again.
What a cost savings that is, even though the investment was there at the time. Right.
And based on those, we did a couple of pilot projects for that school district, and they ended up doing all of their parking lots in permeable pavers. Ended up being about 7 acres worth of pavers.
Wow.
Why? Because they wanted to save money.
Yeah.
Right?
Yes.
Yeah, they're saving money using permeable pavers, because now they don't have to spend all their time out there messing with the asphalt, crack sealing, seal coating, and all that kind of stuff, restriping. So you may have to restripe a permeable paver parking lot once every 5 or 10 years.
Yeah.
Whereas with asphalt, you're going to have to restripe every couple of years, because once you seal coat, you're going to have to restripe it.
And you can even use other pavers, other colors for striping in the pavement as well. So it offers some design and functionality as well. So
absolutely, yeah. And we do see that quite a bit. Sometimes it's it adds cost, but long term it saves money.
Right.
And you can do that, and good contractors can do it. Some contractors I wouldn't recommend it, but most contractors out there know how to cut them in.
Yeah. So I don't know if we've covered this, but let's talk about the construction of a permeable, system, the different types of aggregate. What does it do? Where does the water go? Like what are some of those things we have to look at when we're looking into permeable?
Yeah, thanks for asking that, because there's a lot of misconceptions out there. I see permeable paver systems going in with sand,
right,
as the bedding material and in the joints. There's no sand in a permeable paver system, right. So you're going to have the paver that sits on top, but let's start at the bottom, okay?
Right. Yeah,
so with the soil, most of the time you're not going to compact it, and most of the time, especially in a clay soil, we recommend scarifying the surface, breaking it up, tilling it, making sure that especially if you're designing with infiltration.
Right.
Now, not all systems that permeable, and that's another misconception. You don't have to have an infiltrating soil to use a permeable paver system, right? So you can design a permeable paver. I've done a lot of them in Texas where we have an impermeable liner.
Right.
They still perform all those functions even with a liner in there. So permeable infiltration in the soil is not important. It's not part of the design. I mean, it can be. It's an added benefit, but it's not necessary.
Right.
So you have the soil. Then you place it at a minimum of 6 inches of number 2 stone, which is a 3-inch aggregate, roughly a baseball size.
Okay.
Now, this is for a commercial application.
Sure. Yeah.
Residential is a little different, and I'll talk about that when I get done. But then you have a 4-inch layer of number 57 stone, which is ASTM number 57 stone, which is a 3/4-inch aggregate, all open graded, no fine material in it, which is about the size of a grape. And then on top of that, you have a 2-inch layer of a setting bed, which is number 8 stone, which is about 3/8 inch, roughly a raisin size.
Right.
Okay, so you got 3 layers of stone. You got the big stone on the bottom. Then you increasingly get smaller. And a contractor asked me yesterday, why do you use 2 inches of setting bed instead of 1 inch of sand?
Yeah.
Well, it has a lot to do with the size of the aggregate.
Right.
You can't screed 1 inch of number 8 stone like you can of sand, because sand is a very small particle, so you can easily screed it and get it nice and level. The problem is when you try to screed 1 inch of number 8 stone, you're going to pick up some of that base material, and it's going to mess it all up. So you got to be a little bit thicker. And then the paver sits on top of that. The pavers themselves are not porous.
Right.
The water's not going through the paver. It's an 8,000 PSI, typically 8,000 PSI paver or greater. The minimum is 8,000. What's your poured-in-place concrete? Do you know the compressive strength of poured-in-place concrete?
It's like, well, it depends on how wet it is and how it cures, and from my ICPI
exactly,
teaching, you never know. But when it comes from the plant, it's supposed to be 4,000 or
3,500 typically, or 4,000.
Yeah.
That's in the range, right?
Yeah.
These pavers are 8,000. They're double that compressive strength.
Right.
So they are very durable, but all of the permeability really comes through the joint.
Right.
So permeable pavers have a wider spacer bar on the sides that create anywhere from a 7 millimeter to a 12 millimeter joint. And that's where all the water goes. And there's a column of stone. You fill all the joints with the same material you use for the bedding layer, number 8 stone or number 89 or number 9. And that's where all the permeability comes. You get over 800 inches per hour of water going through. Well, I mean, I don't know what it is in Kansas City, but the 100-year 1-hour storm in Illinois is 3.5 inches.
Wow.
In 1 hour, you get 3.5 inches of water, of rain. That's crazy, right?
Right.
Permeable pavers are 830-something inches per hour infiltration rate. So you never have to design with how fast the water's getting in.
Right.
The whole design concept is really how do we get the water out of the system without it surcharging up through the system itself.
Right.
So, I mean, it's like I said, the water goes through very fast, and it's all in the joint. And it's very, very important, that joint material, because I get asked every once in a while, well, why don't you just put in permeable pavers without the joint material in there? Because the water's going to get in even faster, right? Absolutely, it will. It'll get in faster, but the problem is then the sediment does too.
Right.
And it starts to clog the system from the bottom up. It starts to fill that area that you're trying to store and manage your stormwater with sediment.
Right.
So when you put the joint material in there, all of the sediment gets trapped in the joint. 99% of it gets trapped in the joint. Then we can suck that joint material out using like a vacuum excavator. I see you have a Ditch Witch hat on. Ditch Witch has vacuum excavators that work great for maintaining permeable paver systems. and then you can suck all that out and you can renew the system back to brand new.
Right.
That's the key. That's what really separates our system from a lot of the other permeable pavements out there, is that it is maintainable long term for the life of the pavement system. You can regenerate it back to basically brand new.
Right. And so is the larger size of gravel all the way through, is that for structure or is it for the cleaning of the water?
It's really mostly for structural stability.
Okay.
When you have that, as an engineer, when we would come across bad soil in a parking lot, what did we do? We over excavate about a foot,
Yep.
and then we put in
Larger
3-inch
aggregate.
stone.
Yeah. Yep.
3-inch stone is more stable. Like,
Right.
for residential projects, we recommend you have the either 2 3/8 inch paver, which is 60 millimeters, or 3 1/8 inch paver, which is 80 millimeters on top. And then for residential projects, you can do 2 inches of setting bed and then 6 inches of the 57 stone.
Right.
But if you're going to have heavier vehicles on there, you really want number 2 stone in there, like what I talked about before: 6, 4, 2, and 3, a total of 15 inches.
Right.
The minimum residential section is only 11 inches.
Right.
But if you're gonna if that homeowner has a recreational vehicle or an RV that they're going to park on that driveway, those are the questions you need to ask as a contractor.
Right.
What's the soil type? What kind of vehicles are you parking on there? And whatever they tell you, go in a vehicle bigger. But
Yeah.
those play into, even as a contractor, if you're doing the design. Some contractors do their own designs. You really have to pay attention to what they're going to be using, how much water's coming to it, and start to think about the system in a little bit different way than you would a normal, like everyday impervious paver system.
Yep. And I this information is really good, and I think it's good to understand the process and the application for permeable pavement. I think that a lot of the listeners that I'll have will probably be more focused on residential work. So,
Right.
What are some good applications for using permeable in a residential application? My first thought is a driveway.
Yeah. Driveways are good. Patios, you can use them in patios. Some of the things you'll come across with a patio, though, is about, will the joint material move around? Will it be on the surface? Am I going to walk out there in my bare feet and get a gravel poking me in the bottom of my foot?
Right.
Well, most of the time, no, but there are other products out there like joint stabilizers, which I think are appropriate for residential applications, not so much on the commercial side.
Right.
There's some permeable polymeric sands out there that I think are good for residential projects, especially if you don't have a lot of water draining onto your patio or your driveway. So pretty much pool decks are great because you get a lot of water splashing on there. If you have a permeable pavement system, it'll filter,
Right.
It'll infiltrate down through the system, and it won't sit on the surface.
Yeah, and we talked about that yesterday. And one of the concerns I've had with doing my patios permeable, because I think it's a great idea, especially if we're using an open base anyway,
Right.
and we're trying to collect water and keep not only the water splashing out of the pool, but rainwater we want to go away from the house and away from the pool. So we always end up with a channel drain, or we're pitching the pool 4 different directions.
Right.
So you explained a technique for maybe eliminating. My concern was getting all that water to the bottom of the pool, and if we've drained the pool down for the winter, or something, because we've had fiberglass pools float up after big rains. So
Yeah.
the worst thing I can think about is introducing water to a pool.
Well,
on the wrong side of it.
Underneath.
Yeah.
You can't float a pool like
Yeah.
that. So, it's very similar to what you do around the foundation wall.
Right.
So if you have permeable pavers on a driveway, right where it meets the house, you don't want that water flowing straight down into the foundation drain, because
Right.
I have been out on projects where they flooded the basement because there's too much water
Yeah,
going down through
absolutely,
there
yeah.
into the foundation drain, and now it's overtaxing the sump pump. And this homeowner actually had to get a bigger sump pump.
Right.
So you don't want that to happen. How do you fix that? Well, you use a geomembrane. It's an impermeable liner, and you put it against the foundation wall, and you take it out horizontally far enough so it covers the whole trench that goes down
Right.
to the foundation. Usually 4 or 5 feet is going to be enough. Well, you can use that same technique at the edge of the pool. So you have a big excavation with the pool. The pool excavation is a lot larger than the pool.
Right.
So we don't want the water going down below the pool. So same kind of situation. You would use a geomembrane along the edge of the pool and come out horizontally as far as you need to bridge over that excavation.
Right.
So that water's not getting into the excavation below the pool and is shedding out to wherever you have your under drain.
Right. So you could basically, in the place where your channel drain would be, you could have an under drain in the sub base basically.
Right.
So you could direct that liner, that membrane to that area, and you basically collect the water and send it.
Yeah.
So you still want to excavate, I think that's another area that people miss is, especially residentially, is they're thinking, oh, we're doing permeable, let's do a flat surface, let's do a flat excavation. Well, you have to, you don't want the water by the house, you don't want the water by the pool. You will, if you introduce water, it's going to collect water. So you have to still excavate properly and have it sloping away from the structure or the pool or whatever. Yep. But then also, we got to get rid of that water. So explain some ways to do that.
Well, absolutely. You want to have at least some pitch away from where you don't want the water, right? So you have the house, you want to have at least some kind of slope on your subgrade once you cut your excavation. And most of the time, 0.5%, 1% is plenty. You don't need to go any steeper than that because the water will make its way. It's okay if a little bit of water pools, but you want to get the water away. And the best way, most systems, I've designed millions and millions of square feet of permeable paver systems now, and 90% of the time we have to have an under drain. Unless you're in Florida or the Southwest or something where they have very sandy soils and you get a really high level of infiltration, most of the time you're going to need an under drain. Right. Whether that's with a permeable paver system or if you're using an open graded base, if you have a clay soil, you better have an under drain in there. And and a lot of times it's good to even key it in, like put the under drain lower than the pavement system. Right. That way the water gets in there and gets out. Right. Because especially with clay, if you can go out on your site and you can take a ball and you can make a ball with it and you can mold like a little dude out of it or whatever, that's a clay soil. Yeah. And water has a huge impact on that kind of soil. If you're sand, you're good. Yeah. Sand's very strong and it lets water flow right through it. Clay does not. And the structural stability of a clay is highly dependent on how much water's in that clay. Right. So if you have a clay soil, make sure you're using an under drain to get the water out of the system because we don't want it to surcharge. We don't want it to build up in the system, especially like if you have a patio where you have like a 4-to-1 slope or a slope coming up to it and you don't get that water out, you're going to have water seeping out of the bank, like right at the bottom. Right. And it's going to cause a problem. You're going to get called back as a contractor say, hey, every time I mow, I leave ruts here because it's too wet.
There's a wet spot I didn't have before. Right?
Exactly. So, any pavement, I don't care what kind of pavement, whether it's standard pavers, asphalt, concrete, what makes the pavement work, what makes it the best? The base. The base is the key. Right. So if you get the base installed right, you drain it properly. Water is a huge problem when it comes to especially dense graded bases. Yeah. And compaction. You got to compact it. You got to drain it. And if you do all those things, you're going to have a great you're going to have a great outcome. You're going to have a patio, a pool deck, a driveway that's going to last longer than probably you own the house. Right.
And so let's talk about compaction. Because doesn't open graded base come out compacted when you dump it?
Yeah, 98%. No. Don't use that clip.
We have an engineer here. We've consulted about this, so let's talk about compaction.
That's one of the biggest misconceptions out there is if you use open graded base. I've heard engineers say it. I've seen it in Interlock magazine.
Yes. Yeah.
98%. It's 98% when it dumps out of the truck. That's not true. It takes less compactive effort for open graded aggregate because once you put the compactor on it, what happens is it rotates all those little angular pieces and it kind of settles them down. And if I know you've been out on a job site and walked on loose 57 stone versus compacted, and it's a different ball game. When it's been compacted.
Yeah, and it moves around. I think about the way I compare it to is like a gravel driveway. Like when I grew up, we had part of our driveway was gravel, and every time we put new gravel in, it felt like you were all over the place. And it was moving, and it was trying to find its place basically until it worked itself in. And yes, I totally agree with that.
And that's part of the reason we recommend number 2 stone,
Right.
Especially in a commercial application. For driveways, it's okay. Most of the time, you're not mechanically installing that.
Right.
But if you use, say, 10 inches of number 57 stone, I use the analogy. It's like trying to lay pavers on a waterbed. They
Yes.
move around,
Yeah,
and the
yeah.
trucks will rut it. So the 57 stone provides a much more stable base, especially if you're going to be mechanically installing, because you're going to have heavier equipment. You're going to have maybe a mechanical screed, which is very heavy.
Yeah.
And most residential applications are going to be hand laid. That's why we have a little different section. Plus, you don't need as much structural stability, because it's only going to have passenger vehicles, maybe a boat, at the biggest, maybe a recreational vehicle. So there's some differences there, but compaction is key. And most of the time when I get called out to a project where they're having problems with rutting, with issues like that, when I ask the question, what did you use to compact it? What do you mean? Well, did you compact the layers as you put them in, except for the setting bed? You don't compact the setting bed. You compact the sub base, you compact the base, setting bed, screed it on loose. Well, we didn't compact it. It's open graded. We don't.
Yeah.
Then that's why you have rutting.
Right.
And mic drop, walk away, because it's not our paver, it's not your installation. Because most of the time, the paver contractor is screeding the setting bed and putting the paver on.
Yeah.
Some contractors do all the layers, which I think is actually a good thing, because then you control what you're putting your stuff on. Because most of the industry uses acceptance. So once you start putting your pavers on top of a bad base, now you've accepted that base. So you think about that too as a contractor, and make sure personally, if I was a paver installer, which I'm not, but I would have a representative from my company out there watching them install the base and make sure they're compacting it.
Absolutely, yeah.
And before you start screeding, you better make sure it's well done. And like I said, it's a good thing if you can. I mean, it's a big investment to lay in that stone and compact it. But if you do that, you're master of your own destiny, right? You're taking control of something that a lot of people don't do well.
Right.
And really, from what I hear, and you can correct me if I'm wrong, from a contractor standpoint, the most important layer in the whole thing is the 57 stone. Getting that right at grade, so you only have a 2-inch layer of setting bed on it. Because a lot of times, when an excavation contractor or somebody's putting in that 57 stone, they don't understand that it really needs to be right at 2 inches or 5 inches below grade.
Right.
The paver is 3 1/8 plus the 2-inch setting bed. So that 57 stone really needs to be spot on. It needs to be level. It needs to be ready to go. And then you just screed on right on top of it the setting bed. You don't want to correct any dips or anything like that with the setting bed.
So no different than a dense graded aggregate base.
Right.
Yeah. Where you're wanting to get that within 3/8, plus or minus or something like that.
Exactly. Yeah. And then, the ICPI does have some standards for the sub base, the base, and the paver finished surface, which the Interlocking Concrete Pavement Institute, they do have good installation tolerances that every installation should meet.
Yep. Yeah, because you don't want to see when I teach the class, I spend a lot of time on that, because it's not just that, but it's also your dig. I mean, if your dig is if you have holes in it or ruts in it, and then you start making corrections in your excavation with larger stone or things to get it all evened out before you hit the 57s, and then all right. So,
well, and doing all that thing, if you get the excavation right and you get the stone layers in right, and it's saving you money too.
Right.
If you over excavate, you're not paying attention, then you're paying more for the aggregates going in.
Right.
You want to get as close to the depth as possible.
Right.
Because anything else is coming out of your pocket,
Right.
and it's cutting into your profitability.
Exactly.
If you're putting in those materials.
And it's not just bringing gravel in. If you have to haul off the excavation, then now we have another truckload, or
Exactly.
So,
it's not cheap to haul that stuff off, and it's not cheap to get rid of it.
Right. So in the residential side, and we talked about this a little bit yesterday, so I'd like to touch on this because it's becoming very popular all over the country, not just in certain freestyle areas, but we've kind of most contractors have gone from the dense grade aggregate and sand to kind of a hybrid system. They're not calling it permeable. They're calling it, open graded base or hybrid installation. So they're using a 57 stone. They're using a 3/8 or a 1/4 inch or whatever. Canada's there's or some areas around the country here in the U.S. there's the HPB or whatever. It's a really nice, consistent 1/4 to 5/16 product. But then they're putting either a polymeric sand in it, or they're doing like when you talked about maybe a resin sand, or like like Technoseal has like a storm. So they're using these other methods. So it's permeable in some ways, but if they're using polysand, it's more of a runoff system, kind of more controlling what you're talking about with freeze thaw and water storage and movement.
Right.
How do you see that installation, and is it something that's you think will be accepted by ICPI at some point, or do you think that we're just moving that direction? And what do you, as an engineer, how do you feel about that system?
What? Couple things. I want to put out there. The Interlocking Concrete Pavement Institute right now does not recognize open graded base as a approved system.
Right.
Now, that being said, the horse is out of the barn.
Right.
I mean, a lot of contractors, especially where you have heavy freeze thaw, like in your market in Kansas City, we see it a lot in the north, not much in the south.
Right.
Where they don't have heavy freeze thaw, there's not a need for open graded base. Most of the time, I've talked to some of our people down in the south. They're not seeing it.
Right.
But in my market, in Chicago and in the northern areas, especially in the lower Midwest, where like Kansas, Missouri,
Colorado.
Colorado. Yeah, well, Colorado has like some of the worst soils out there.
Yeah.
But we're seeing a lot of contractors go into open graded base. Why? It's the freeze thaw issue. Water gets in there, expands 10%. It's not heaving.
Right.
And it really helps the contractor because they don't get called back to the site for issues with the pavement surface due to frost heave. And I'm going to be honest here. I built my patio with open graded base.
Right.
Why? For those reasons. I did not want the frost heave to be an issue. Because the problem when you use a dense graded base with sand, you can make it work in any climate.
Right.
But the problem is people don't drain it properly.
Yes.
And when they don't drain it properly, then the sand gets saturated. And as soon as the sand gets saturated, then it freezes and it heaves the paver system. And I've had pushback from cities and things saying, hey, pavers heave. Well, no, you didn't do it right.
Yeah.
But it takes some of that. When you do open graded base, it takes some of that out of the mix, especially if you're going to be really flat. If you're going to be 0.5%, 1%, you should look at open graded base because it is much more forgiving than a dense graded base with sand. And you don't have to be you still have to drain the water out. You're still going to have to put in an under drain, but you're not going to have water. You're not going to have any frost heave. You're not going to have water on the surface. So if you're getting down where it's really flat, your homeowner wants their patio. They want to have the table sitting on the patio and the ketchup bottle won't roll off.
Right.
Right. So at 2%, it's going to roll off the table.
Right.
So, if you're getting pushed from your homeowner for a flatter surface, then I think open graded base is a great solution in that situation.
And I think there's some misconceptions too. Like it's kind of like everything. It's like it's all or nothing. Like some of the people that do open graded base say that the dense graded and sand is the system's failed and it doesn't work, and I disagree with that.
Right.
There's applications where, and I've done plenty of patios with that system. That's how I started, and I think where I think some of the disconnect is as an ICPI instructor and doing classes and hearing people's stories. I think I try to remind people that the ICPI system is dense graded aggregate, sand, and then a sand joint.
Right.
And it's there to create interlock on a paver size, which is less than 101 square inches, or somewhere in there. So what we're seeing in the industry is more of a slab look, right? So you're not creating interlock with this anyway. So in that case, you can create a system on open graded base and use different kinds of sands.
Yep.
But also we saw a lot of failures with polymeric sand in the sand bedding layer type installation, because the sand will, once you wet it in, or if it rains or you get water in there, then the sand doesn't necessarily set up from the bottom up. right?
Right. It's dry on top and it's wet below.
Yes.
Yep.
So the polymeric sand isn't curing properly, and so then if you say that the ICPI method fails, well, they're not really telling you to do polymeric sands, right?
Right.
They're saying to use a sand fill and then do a stabilizer, or I mean, you can use those types of things, but you have to make sure you're getting that drainage, and getting the sand to set up, I guess.
Well, yeah, absolutely. And the Interlocking Concrete Pavement Institute is a great organization, but they're a very large organization, and it takes time for them to change and to update where they're at. So they're researching open graded bases right now. I think they're going to come out with some kind of guidance on that. But in the meantime, we're at a point where people are doing it,
right?
And we have to adjust,
right.
In real time, a little quicker, I think, than the bigger organizations can. And open graded base is a good solution. One thing this is a good question for you, Craig. I'm going to interview you now. Do you have to use more polymeric sand in an open graded base? Do you get a little bit of loss into the setting bed, or no?
See, that's another thing that I've heard, but I don't think I notice it because it's a 3/8 stone. You may lose some, so we're sweeping it in. Just the other thing is on
I say 5 to 10%, but
right.
I'm not sure if that's.
I think that's probably fairly accurate. I think it depends on the joint size as well. Like if we're using a Belgard product like Dimensions, that's barely enough room in the joint to get the sand in there. So.
Right.
And then you have some other pavers where the joint size is going to be bigger. It's going to sweep in more. So I think it's depending not just on the base or the screen layer, but like the paver itself. Right. So I would say 10% would probably be. And to me, that's okay.
Yeah, that's fine. Another thing you hit on too, I want to expand a little bit is the definition of a paver.
Right.
Right. We call a 12 by 18 a paver, but that's not a paver. A paver it fits a very specific definition, right, according to us. That's Paver Nerds.
Yeah.
Is a paver has to be at least 60 millimeters thick.
Right.
It has to have a face area less than or equal to 101 square inches, and it has to have an aspect ratio of 4 to 1 or less.
Right.
If it doesn't meet those categories, if it doesn't meet all three of those definitions, then it's not a paver. We call them pavers, but they're not pavers.
Right.
They're slabs.
Yeah.
What's in between? And a slab has a definition as well. There's an ASTM standard for pavers. There's an ASTM standard for slabs. What about all the tweeners? What about the planks?
Yeah.
Well, they don't fit into a category. There's not an ASTM standard for planks. But once you get outside the paver definition, which, like I said, is 60 millimeter thick or thicker, 101 square inches, and an aspect ratio of 4 to 1. What is the aspect ratio? Is it like your TV? No, it's not your TV. For us paver nerds, aspect ratio is the length of the paver divided by the thickness.
Right.
So a 4.5 by 9 paver is 9 inches long, divided by 3 inches thick. Well, 3 1/8, but I can't do that math in my head. So 9 divided by 3, I can do in my head. That's 3 to 1.
Right.
That's where you want to be for vehicular applications. Residential, you can get away with a 60 mil paver in a driveway sometimes, just depending on the kind of vehicles. But pavers fail due to compressive strength issues, right? They're 8,000 PSI. You're almost never going to have a failure on a paver that's properly manufactured. But with a slab or a plank, that's why we lump planks in with slabs, because the failure of those type things, you got a long, thin piece of concrete. Concrete doesn't do well in tension.
Right.
So if you have a concrete beam, what do you put in the bottom third of the beam? Reinforcing steel.
Right.
Why? Because concrete's not good in tension, and tension is in the bottom of the beam.
Right.
So the concrete transfers the tensile forces into the steel.
Right.
We don't have steel in a concrete paver. They're not good in tension. So slabs and planks, they're going to fail due to flexural strength. Our compressive strength is 8,000 PSI. ASTM C1782 for slabs is a flexural strength of 725. 8,000 versus 725 PSI flexural strength.
Wow.
So that's why it's a completely different category, and we really need to start calling those slabs and not pavers. Because a paver, like I said, it has a very specific definition, and it functions much differently than a plank or a slab.
Right, and you're not going to compact like the final compaction where you're compacting in the actual pavers to create interlock. You're using a completely different method to do slabs. You're using a roller compactor with less centrifugal force, and you don't really want to put too much pressure on them because they can crack. Even we've had a few crack under roller compactors. Some of it comes from maybe your base is off a little bit. So then you're just to what you were talking about. There's that tension, and if it's not setting evenly or on your screening layer, then it could cause it to crack. So.
And you know, especially if you're using an open graded setting bed and you're putting a slab on there, you better have it dead on.
Yeah.
Because what happens is when a lot of times that cracking will occur because there's maybe a stone or something that's kind of teetering on there.
Yeah.
And then it'll create that movement that'll cause it to crack.
Oh, that's not a manufacturer defect.
I mean, it could be.
Sorry.
It could be. I mean, you know, not every product we make is perfect.
I just want to throw that out there.
Yeah, well, no, I mean, you know, just like everything, you know, I mean, there's some pavers that aren't up to standard. I mean, but
it was more of a sometimes every time something fails with a paver, it's the paver's fault, right?
Well,
so but there's always other factors to look at, you know, and where do
Yeah, well, you know, I mean, that you know, first place they look is at the contractor. He didn't install it right.
Right.
Next place they look, well, the paver's not right.
Yeah.
And you know, and then it goes to the design. And you know, I mean, most of the failures I see are a kind of a combination of things. You know, I mean, sometimes it's the installation. Honestly, sometimes it's the product. Occasionally, not very often. And you know, and a lot of times though, what I see is the design is not up to standard. You know, and it's nothing against architects, landscape architects, or engineers, but the problem is they don't know how to design the system, and they don't understand that there are design standards for both permeable pavers and standard pavers published by the American Society of Civil Engineers. So ASCE has a paver standard for ICPs and municipal roadways and streets.
Right.
It's ASCE 5816. And they have a permeable paver standard, ASCE 6818. And I think there's just not good awareness in the design community about these standards. So people don't do it. Then when there's a failure, you know, I ask them, how did you design the pavement?
Right.
What standard did you use? What?
Yeah.
You know, they don't know they exist. So that's part of my job, is really trying to get out and spread that news.
Right.
There are design standards. Please use them because they're going to help you. If a pavement failure happens and you have a calculation showing how you designed it, you're in a lot better position than if you don't.
Yeah.
And I mean, even from a contractor standpoint, you know, I mean, a lot of contractors do their own design build projects, but especially with a permeable paver system, unless you have done it a lot and you know what you're doing, it's probably a good idea to talk to, you know, a civil engineer and get their input at least, and maybe even hire them to do a design, especially because you're handling stormwater, depending on how much of the yard is draining onto your permeable paver system. If it's just the driveway itself and maybe a roof drain, you're probably okay. But if you have a lot of the yard area that's coming to it, you got to look a little deeper. You got to look and treat it a little differently. So it might be a good thing to get to know a civil engineer and maybe hire them occasionally to work on those projects, because you don't want to have something, you don't want to flood somebody's garage or have an issue. So, you know, and or call me.
Right. Yeah.
I mean, I do this kind of thing all the time. I help contractors, I help engineers and architects, landscape architects design our systems.
Right.
That's my day-to-day job.
Right.
So, yeah, I mean, reach out to go to belgardcommercial.com, and you can find my information, or anchordiamond.com. And you can find my information, and we can help you.
Okay.
We can help your engineer. We can help you as a contractor. I do a lot of work with contractors, actually. So it's you know, we have this service available to people. It's not something we charge you for,
right?
Because we want to make sure our systems are designed and installed properly,
right?
because it helps us. Because anytime there's a failure, they look at us, and then if it's not our product issue, then we get it shakes out. But ultimately, the success of all the projects that you guys are installing with our product is good for all of us.
Right.
And we don't failures. People remember failures a lot more than they remember successes, right?
Yeah.
That's how you learn.
Yeah.
But we want to make sure that it's installed correctly, that you guys have the resources that you need to do that, and we have a team of experts that we employ to make sure that happens.
Right. And you just answered my question, which was how can you help a contractor? So that was great. So, and I don't know if you can expand on it, but I think you pretty much nailed it with that. So
I will expand on it just a little bit,
okay.
because we do have a guy. He's been in the industry for eons. He was a paver installer for 40, 50 years, named Chuck Taylor. So and just recently, he and his son went out to a job site and helped an installation contractor, a contractor that was installing a large job with a mechanical screed, and kind of gave them some input and helped them figure out how to better use that screed machine. So we have a lot of resources even for the contractors, because we have people who have been doing installation for eons. I mean, long time. And so, from a design standpoint, we can help. And from an installation standpoint, we have the resources to assist you build your business. And that's what we're here for.
Yep.
Because the more successful you guys are, the more successful we are.
Yes.
And it starts at your level. It starts at the contractor level, because without the contractors, we got nothing. We don't sell anything.
Right.
So that's what we're here for. We want to make sure that you guys have the resources you need to increase your business, and that's what we want to support you.
Well, I appreciate your time. I'm really glad I ran into you yesterday, and that we kind of talked about doing this, because I think it's very informative, and it maybe sheds some light on another part of the industry that people maybe are seeing a need for, and not necessarily there yet, but they're kind of interested in. I've always had a high interest in permeable pavement, so I appreciate your time. Thank you for being here. And you said we can go belgardcommercial.com.
Yep.
Or anchordiamond.com.
Yep, anchordiamond.com. You can find any of our experts. We have a retaining wall expert.
Yep.
We have paver experts. We have rooftop applications, for pedestal set and all kinds of things like that, rooftops. And so we whatever project you're working on, we have somebody that can help you improve that.
Great. That's awesome. Thank you very much, Paul. And man, let's go kill it for next year.
Yes, sir. Thank you. Thanks, Craig. Really appreciate it.